Question 29, this is one where we're going to go straight through from a scatter plot, looking at the regression, looking at something called the coefficient of determination. Now this has been found when you've been finding your correlation coefficient. It really is a measure of how closely your plotted data points lie to the fitted trend line. So we quote it as a percentage, so such and such percent, the variation in Y can be associated with the variation in the X figures. So in 29, prepared this graph, and then you can see here my line of best fit shown with a dotted line. We're by far better off now using our graphics calculator in order to find that. So I'll just produce that up. I've entered the data, copied the formula, and OK. Now at this point, write down the figures. So you've got your gradient of 1.79 and your y-intercept of 81.08. So if you record that, the R squared figure is 0.9743. So if we record that, P is equal to 1.79W, not Y and X, but price relating to the weight plus 81.08. So working that through, R squared is 0.9743. Now that means your coefficient of determination, 97.43% of the variation in price, can be associated with the variation in weight. Now please notice we're not dealing with a causation, we're dealing with a discussion looking at the strength of the relationship. The correlation coefficient and the coefficient determination give us an idea of the strength of the relationship. Progressing that through, if I want to predict from the graph in part D, I've looked from there, 250 along, and I get around about 530. Now running that through my predictor here, about 528.51. From the graph in F, it's not a bad graph, but it's an extrapolation. It's not that reliable because I've gone beyond the data. But if I make that prediction, you can see here about 960, putting into my equation, about 940.21. And a similar way with my prediction for H, where for 600 price, you can see here, of the order of 260 kilograms, and when I've worked that through, 278.77. The key thing when you're dealing with an equation such as this, it's pretty well modeled. It fits pretty well. B, we're making predictions in the cases of D and H from within the given data. We've got solid data points around it. We're really extending beyond what we know in the case of F. So when we start talking about reliability, we say predictions are reliable. If obviously we've got a reasonably good line of best fit, fair enough. We've got a reasonable number of data points. In the real world, we'd probably want a lot. In this instance, we're not going to get them, but within the realms of sensibility, these are going to be pretty reliable estimates. That's going to be less reliable. And in a moment, I'll work you through J, and show you how we can write that. So we can write something of the following. We can say that D and E, combined, H and I combined, can be considered reliable. There's a strong association between the variables. I can talk about the correlation coefficient if I had that as well. Very high coefficient determination. We've got a reasonable data size. And interpolation has been used. It's within the given data. However, the G and F are unreliable because that 480 kilograms goes beyond the given data. So we'd say that's extrapolation and unreliable. Please get used to not only using the phrases extrapolation and interpolation, but explaining what they mean in the context of the given question.